Thank you very much. How much time do I have? You are supposed to have coffee in 5 minutes.
No. We will, your presentation will be more interesting than coffee.
I'll make it as quickly as possible. Thank you. I think in the following the papers that we have here, we have a lot of data, but sometimes right now we need to update the data. And the question of updating the data depends very much on the geographic databases that we are having. So historically, there's just a review, and with some of the examples, you can see that one has tried digital files with CAD, computer-aided design methods. And this was a graphic approach, and okay, many countries have started the graphic approach with CD applications, but it is not possible to update the CD applications. If you try to do that sort of thing, it's much better to map completely new. This has led to a great amount of difficulties, because if you want to renew, for example, the situation of a city, then in that case, you throw everything away, and then you have to do everything. That's fine for the mapping enterprises, but it's not efficient from the point of view who pays for the funding. I'll give you some of the examples of the CAD mapping as it was done in 1980 in Kuwait, and this is being done still in Saudi Arabia now. The approach that has been taken by other countries has been rather interesting. For example, one of the best topographic systems for the scale 1 to 1,000 is the Ordnance Survey Master Map. It's totally object-oriented, which means that you can update all the objects that have been defined by an independent method, either photogrammetry or by the simple tool by GNSS or GLONASS or whatever. We have in Germany also another system which is called the ANA system with the predominance of the cadastre. The British system does not contain the cadastre, but it is a complete system for topography. And then the question, we have the fast approaches like Google Maps, Bing Maps, Yandex, and things like that. But these are also not object structured. So this is a typical example from 1976, a map, Kuwait, which was done by a Japanese contracting company. And the question was, there were something, at least 400 codes of sort of, it's absolutely impossible to maintain 400 codes. So what one has done, for example, in Saudi Arabia, the situation is very similar. One has grouped the codes into domains, at least, but still you can see that the number of codes, main feature codes, is in the order of maybe 400. And for each of these feature codes, you have areas with specific tools, and every company that maps gets these specifications, and they just have to do it new. And oops. Okay, here we go. And this is a result of a map that you can say. And of course, while one has gone ahead and used ArcGIS formats, from that point of view, right now at least you have an internal topology. But still, the objects are not defined. That depends upon the database. And you can, of course, try to update by superimposing imagery. Then you will find out, do I have to do mapping again or not? Then you throw one part of the map out and you renew it completely new. That's one of the ways to do it. But what is different in 2D for object-oriented systems, and these are the two examples, Ordnance Survey and the German system. Here, every building and every creek and every road has been identified as an object. It can be addressed. This means that when you go there, if it's addressed, if some changes, you go there with your local tool and you can just change it. You don't have to do the entire map, but you change the object. And the way the British Ordnance Survey has done that, they've identified the objects, for example, by so-called topographical object identifiers. And this is quite a lot of work because the transport network has 1 million features, 26 million addresses, and 400 million topographic things. So, and the master map object at the scale 1 to 1,200 in populated Britain is going to be built up having addresses, imagery, tins, boundaries, height, land use, and building codes. In Germany, the system is built on the cadastral system. And the cadastre in Germany does not only contain proper boundaries, but also buildings, which is very important. At least you can model the buildings. The only problem is that the topographic map is based on the scale 1 to 10,000, not 1 to 1,000. So Britain has better large-scale tools. Anyway, that's a question of the organization between municipalities and between the state. And the difficulties, if you don't do that at the scale 1 to 1,000, like they have done in Britain, is the link to the utility providers. But nevertheless, the tool of the AAA system, it's an integrated system. Why is to say, it contains the motivation, the numerical cadastral map, the land register, and the topographic map, all together. And I will just skip that. You can simply see the real estate map is at a scale 1 to 1,000. Then the topographic system, ATKIS, is at the scale 1 to 10,000. And then you have the land register, which is tied to the whole thing as an object. And this is the AFIS, that's how it's called, AAA. AFIS is a point information system with all the coordinates. And then this is the cadastral system, which contains the buildings and the property boundaries. And this is topography, which contains digital landscape models, topographic maps, and orthophotos. And this is all modeled internally in the database. And of course, for the output and for generalization, you have to develop a cartographic model on the side. And that is different for the different scales, including generalization. And the structure of the object catalog is then for example, the domains or classes, like we have seen for roads, for traffic, for vegetation, and so forth. And then you can combine them in such a way, and you have to harmonize the object catalogs. There are quite a number of object features, as you can see. Countries with poor mapping infrastructure, they don't have that, of course. You can see when you use Google Earth, it's not object-oriented. It's very nice for viewing, but not for maintaining data. Good example is when you take the mapping of Nairobi. In Nairobi, this is the official map, 1 to 50,000, of a slum where they're living about 1 million people. And you see Google is much better. So then you have to go and model for the GIS in the way you do it. That's a tremendous effort which cannot be done very easily. So the conclusion in 2D is, due to the different administrative structures, the different countries have used different models. None of the systems is an ideal system, but the optimization leads to different local implementations. And it's not only important to design geodata systems which are updatable, but the issue is often neglected. This is why now this can be expanded into 3D. We have talked, 2D is just as important as it is 3D. Now, in 3D viewing, when you have Google Earth or Esri City Engine, For viewing, there's no modeling. You just look at the image, and that's wonderful. But on the other hand, and I suppose Armin Rügen is going to come back in there, the modeling of city 3D information, that's a standard, a new standard, city GML. And so this is the difference. For example, in Hamburg, city of Hamburg, you have 3D viewing on Google. That's very nice. It's not for modeling, but nevertheless, you just see it. And the question is, 3D GML has been promoted as very interesting, and there are various tools, S3GIS, Google, and so forth. They have tried to cover 3D. CityGML has been developed by a group of academics in North Rhine-Westphalia, together with industry members, and it has become an OGC standard in the meantime. And these lists the various municipalities that have been part of this particular effort, and the various universities. So it's industry, academia, cooperation. It was started to be developed in 2002, and now an official OGC standard 10 years later has been established. So how is CityGML looked into the various situations? Okay, when you look at the, it's of course a tremendous effort to model all the buildings, but the question is, when you want the viewing, and okay, you stay in the GIS world here, and then comes the CityGML in here, and finally it goes inside the buildings at the BIM, building information model. So you see the various sort of things, the various tools that you have. CityGML is somewhere in between, and here it goes to the great details. It is within the standards right now. It falls very well into the scheme XML, GML, CityGML. And then the basics, you can read this. And right now, okay, the question, what you have to cover is geometry, topology, the appearance, and the semantics. And this can be done to various levels, of course. The regional model is the level of detail model 0. City model in blocks only is LOD 1. And then with roof structures, which you need in Europe, for example, you need LOD 2. And then you can go to level 4, which is the, actually already the BIM model. Just to show you what you have to model for each individual building: LOD 1, LOD 2, LOD 3, LOD 4, right? And so each one is a city object. And this, then the question is, you don't have to do it all at the highest level. So the city of Hamburg, for example, has divided zones in which they say, okay, only the inner core has LOD 4 or LOD 3. And the outside can be LOD 1. And what you have to do there, if you want to be, then you can have, of course, also the individual facades. They have to be modeled accordingly. So the building structure has to be modeled. It's a tremendous job. And you can go and do the same thing for digital terrain models. So that finally, right now, you can have traffic areas modeled, railway tracks, and whatever, and the facades. Examples that have been done were various cities, the city of Berlin and city of Karlsruhe. And the question, there are various software approaches that are supporting GML. Very recently, it's also ArcGIS 10.2. So the companies are adopting to that. A good example is the CityGML model of the city of Berlin, where you have modeled 55,000 detailed buildings. And now the question is, when you model them, you may not rely on the situation that everything has been done properly. You always estimate that you are pre-processing, then comes the post-processing. But the reality is really you have done very little on the end, so you have many mistakes. What are the mistakes? Okay, the mistakes are shown here. That you see, okay, there are overlaps and things like that. So this solid modeling is very much more complicated, but it can be done. It's just a question of, okay, I'm not supposed to, it's going back or what it is? No.
You like back or?
Yeah, okay. The question is, what can it be used for? I think city GML is very, very important, very useful for planning and designs. So when you plan a city, like integrated city or smart cities, when you do that sort of thing, you can have the various options that are being modeled. You don't have to do it for the entire city. So who buys this? This is a big question that you have. So the designers for the planning authorities, they should be the ones. What are the standards? City GML is a standard. What is the required accuracy? You can decide yourself by the LOD level that you have to assess. And which standards should be used? You can use vertical oblique imagery, you can use GNSS, whatever you have. And global projects, there's a big question. It's a question of cost. It's very complicated, but the smart city initiative in China, for example, is a very interesting one. So we are looking at it, and there's a lot of research there, and the practical application is wanted. Thank you.
Thank you very much.